In section 4.1, I will be discussing exponential functions. In particular, in this video, I will go over all the concepts and formulas needed for this section. However, to view examples, please make sure you read the notes posted on Canvas for section 4.1. Let's begin with exponential function. F of x is equal to b raised to the x. So an exponential function is when your variable x is actually in the exponent position. Your base, b, must be greater than 0 and it cannot be equal to 1. Let's take a look at the graphs of an exponential function. Now, when your base is greater than 1, it means your curve is going up and to the right. However, when your base is a fraction, a number between 0 and 1, it means your curve of the exponential is actually going down to the right. However, in both graphs, it has a horizontal asymptote at y equals 0. Next, I want to talk about the transformations of an exponential function. If I have f of x is equal to b to the x plus c or minus c, if I'm adding or subtracting on the outside of the function, remember that is a shift up or down. If I have f of x is equal to b raised to the x plus c or x minus c, if I'm adding or subtracting on the inside of the function, remember that's a shift left or right. And now the left and right is a little bit backwards. If it's plus c, it's actually a shift to the left. And if it's minus c, it's actually a shift to the right. And recall, if I have f of x equals negative b to the x, or f of x equals b to the negative x, a negative represents a reflection. If the negative is on the outside of the function, it's a reflection over the x-axis. And if the negative is on the inside of the function, then it's a reflection over the y-axis. Next, the natural base e. So just like we've all heard of pi is equal to 3.14, etc. Alright, e is also a number in math, and it's approximately 2.71, etc. And we call this f of x equals e to the x is called the natural exponential function. And we need this as we lead into our finance formulas. I have I equals PRT, A equals P times 1 plus R over N raised to the NT. I have A equals P times E raised to the RT, and I equals A minus P. So let me know which formula is which. So this first one, I equals PRT and I equals A minus P, that represents simple interest. A equals P times 1 plus R over N raised to the NT, that represents compound interest. And A equals P times E raised to the RT, we nickname that PERT, that represents continuous interest. Over to the right, you can see I've labeled what all the letters mean. P represents your principal, how much money you're originally investing. R is your rate. Remember, when we do our calculations, it always has to be as a decimal. T is time. Again, it always must be in years. N is your compound period. I represents your interest, and A represents the amount of money you have at the end of time. And note, for your N value, your compound period, if the word problem says semi-annual, N is 2. If the problem says quarterly, N is 4. If the problem says monthly, N is 12. And if the problem says daily, N is 365. But do be careful with daily. Sometimes books use 360, just to keep it an even number. And of course, there's always holidays throughout the calendar year. So just make sure you read the problems carefully, in particular for daily, in case they don't use 365 on your math lab homework. All right, real quick, just a couple other characteristics of exponential functions. Let me go back up to the graph so we can take a look. You'll notice the domain of an exponential goes from negative infinity to infinity. And the range of the original exponential function goes from 0 to infinity. Now, of course, if you do any shifting to your graph, that may change the range of your function. This particular graph is 1-to-1 and does have an inverse. We'll look at that in future videos. And again, y equals 0 is a horizontal asymptote. The original exponential function is going to pass through the point 0, 1, and it will not have any x-intercepts before shifting.